Yes.
Okay, great. So thank you all for coming on behalf of the STS Committee, Information Literacy Committee. This is Kelly Try, and we're happy to welcome today Zachary Painter, who is the Engineering Librarian for Research and Teaching Support at Engineering and Research and Teaching Support Librarian at Stanford University. So prior to coming to Stanford, Zach was the Engineering and Data Services Librarian at the University of Massachusetts, Dartmouth. Zach is passionate about teaching and instruction, with certification as a software and data carpentry instructor, and formerly as a highly qualified high school social studies teacher. Zach is also active in several professional organizations, including the Engineering Libraries Division of the American Society for Engineering Education and the Engineering Division of the Special Libraries Association. So Zach, welcome, and we can begin.
Good afternoon, everyone. It is afternoon in the Pacific, so I assume that most people watching this, it's afternoon for you as well. I do want to begin by saying that this presentation, when I originally submitted it, I was working at UMass Dartmouth, and so a lot of the examples, pretty much all of the examples, stem from UMass Dartmouth and what I was doing there. And I also want to thank ACRL for allowing me to interlope a little bit. And even though I'm not formally a member of STS, it's nice to be able to present. So I'm going to tell a little story, which is basically about a student that I know pretty well. And it's the student that I know pretty well, did major in engineering as an undergrad, majored in another subject. And the student as an undergrad didn't use a library, like, at all. And they would study in their room, didn't really speak to a librarian at all. And eventually, as a senior, they had to do a capstone project. And this capstone project, they got some advice from their professor about where to look, and they went off and found a few other things in the library, but didn't really ask for any help, wrote a paper, and that happened. Well, this student was actually me. This is what I did as an undergrad. I rarely used the library, and as I feel that my capstone project would have been a lot better. Not that it was bad by any means, I don't think. Got a solid grade on it, but it probably could have been better now that I think about it and know about it a little bit. And so when I thought about this presentation, one of the things that I thought about was not just the experience that I had as an undergraduate, but framing it around something within a similar concept within STEM librarianship, which is something that I saw with senior engineering students. So program that I had, a little introduction of what we'll do today. What did I cover, and how did I relate it to the frameworks of the ACRL? How did I build the program out? What could I have changed? What could I have improved on? And then how would I transition this? Because it's very clear to me after I've been at Stanford for not quite 3 months now, it's very clear to me that there's some differences. And how would I take the work that I've done and build it out? So senior design as a class is a capstone class. What happens is that engineering students will, usually with some sort of industry partner, this is pretty common. The MBTA, there were ophthalmologists, Raytheon partnered with some students. There were many corporations and businesses and government entities who are interested in working with senior engineering students on projects. And some of these projects were they were typically the nice-to-have projects, or they were prototyping projects in a way. And it's a really good chance for students to work together collaboratively and actually design something. And engineering curricula is based on problem solving. It's based on figuring things out as you go. It's very lab-based. The curricula is very dense, very packed. There's a lot of statistics about how engineers really struggle to graduate in 4 years because there's just so much that you need to put into the curriculum. And it's hard. A lot of the math and the physics behind engineering is very, very difficult. And students do struggle. But there's a growing emphasis in engineering curricula today to move away from the lab-based work. The lab-based materials are still very important within engineering, but now there's this greater emphasis on holistic engineering, or the liberal arts of engineering, the sort of soft skills that you would need to be successful, because a lot of engineering now is about communication. It's about writing, and it's about taking your product and being able to, for better or for worse, market it. A lot of what you see within the advances of engineering isn't just who can design and manufacture the very best thing, but who can understand the needs of the client, whoever the client is. So typically librarians teach the literature of the field, and depending on the curriculum that you're in, or depending on the subject that you work with, you'll have a different level of embeddedness into this curriculum. I've seen some colleagues of mine at UMass Dartmouth who were they were in and out of classes all the time. And then I saw other majors and some of my engineering ones too, it was less frequent. And this is something to look for. Librarianship is changing, and we want to have, I think there's a growing emphasis on librarians wanting to teach more and wanting to be in the classroom more and wanting to do more things with students and with even faculty who are willing to be taught, which isn't always the easiest thing to get. So why did I even bother with this? Why did I decide to go for this? Because can you really impart anything on the students who are just about to leave? Like, I think about the example of me as an undergrad. Is there really something you could have gotten through my head as a senior? Is it really worth it? And I never had gone to the library, and a number of my students who were in the engineering curricula, they didn't really go much either. Are they ever going to start seeing you or start using the resources that you have? But there's a couple of reasons why I actually cared about this and why I wanted to do this. One is partially out of expectation. You know, this is your job, right? You're supposed to go do this thing. And I'm also very passionate about teaching, but related to the ACRL frameworks is this concept of searching as a strategic exploration. This is literally what design, engineering design, and design thinking are all about. And from the frameworks themselves, novice learners may search through a limited set of resources, and experts may search more broadly and deeply to determine the most appropriate information within the project's scope. And then, likewise, novice learners tend to use just a few search strategies, while experts will select from various search strategies, depending on the sources, the scope, the context of information they need. And a very big part of engineering is what are the improvements and efficiencies and ways that I can make something better. I think that's a common trait that's shared by a lot of humans, not just engineers. How can I make this thing better? How can I improve what I have? It's the very heart of engineering and almost the very heart of humanity today. Why wouldn't we teach these things? And I also noticed something pretty early when I was teaching this, and that was that students, graduate students and students who had graduated, they contacted me and they asked me for help with finding some literature. And I was sitting down and thinking about it like, did they not get this at any point? Like, why are they coming to me now? Shouldn't they have gotten this at some time before? And that to me was a reason why to bother. Maybe somebody will come and learn something, even if they are seniors and they've got one foot out the door and they're ready to get out. Maybe they will pick up something, and maybe it will be carried with them. And that, to me, is part of the essence of teaching. Teaching is very much about making a connection of some kind. It's not just about imparting knowledge, but making a connection. So what did I cover in these classes? In the early editions of these classes, so originally this was proposed to me when I interviewed at the school. There was one faculty member who came to my interview, the formal presentation, and that was the mechanical engineering senior design instructor. His name was Don Foster. And Don had previously taught technical writing and was then later on moved on from technical writing, and he became the instructor for senior design, and he became one of the lab managers in mechanical engineering. And it's a bit of a cheat code in a way because Don's wife was a librarian. So in many ways, he kind of got it relative to most other engineers, or if I want to use a pop culture word, maybe he was woke to it. But this is something I'll come back to, but it really helped to have a faculty member who was interested in this. And when I first started, it was just mechanical engineering senior design. At UMass Dartmouth, there are, within the College of Engineering, 4 major engineering departments that would fall under the corpus of this particular project: mechanical engineering, civil and environmental engineering, electrical and computer engineering, and bioengineering. There are other departments, but they don't go through the same process as these students did. And initially, I just had one lecture in the fall and one lecture in the spring. And that was it. That's all I got with them. And in the fall, I covered article literature and patent literature. And in the spring, I covered 3 items. I covered standards, I covered vendors and suppliers, and I covered competitive intelligence. And later on, I would expand upon this. Initially, Don really stressed 2 things. He really stressed the literature of the field, the printed literature, be it articles, be it patents, be it technical reports, and standards. And he really stressed vendors and suppliers. The biggest thing that he really wanted out of the spring lecture was something about vendors and suppliers. How can students go and purchase materials and components that they need so that they can create their projects? Because one of the things that he stressed to students was, you can't fabricate everything. You can't make everything. You're not going to have access to everything. You will have to buy some things. And that was part of the reason why I wanted to put competitive intelligence in as a field, to sort of bring another dimension to purchasing, and bring another dimension into those negotiations. Later on, in successive years, I moved standards to the fall semester. It was a lot to cover, and it was a lot to build on to cover article standards and patents in one go. What I was banking on was the fact that all three of these topics I've seen students before, and I've talked to students before in previous classes. And this is something I'll talk about a little bit later, but my hope was that the fall lecture wouldn't be the first time that they've seen literature of engineering. That students would come into the class and maybe they don't totally remember where to go for the literature of the field, but something triggers in their head, oh yeah, I've seen that before. Yeah, that makes sense. And then later on, I had read a piece of literature suggesting about talking about data management concepts within engineering undergraduate courses. And one of the things that the researcher did for this, which was, I think, pretty clever, she framed it as project management. And that was sort of her way in. And I actually really kind of liked the way that she framed it that way. And project management being a increasingly important and integral part of the engineering design process and the engineering curriculum, I thought this was something that was good to add in. Don somewhat disagreed with me. He wasn't as fond of this piece. He thought it detracted a little bit from what he wanted in the core part of the lecture with vendors and suppliers. So I didn't cover it as much in depth as I probably would have liked to have. But that was something that I was able to negotiate and work out with Don. And one of the things that I also did was each year, I taught this 4 times, and each year I added on another department. So the first year it was just mechanical engineering. And then I had been teaching some classes for the bioengineers. And I had a good relationship with the chair, who just happened to be the senior design instructor. And he said, sure, I'll bring the bioengineers in. So the bioengineers came in the second semester, the second year that I taught this, for both the fall and the spring. And then the third year, I finally got through the electrical and computer engineering students. Had a change of instructor, and that instructor wanted to integrate the curriculum a little more with the others. And I was able to, with help from Don, convince the new electrical engineering faculty member to allow their students to come in the class. And then finally, the last year that I taught it, civil engineering added on. Civil engineering had actually, prior to that point, not been a part of the other senior design classes. They had done a separate project, which I'll talk a little bit more about that, but it was a project that was different, and they had a different curriculum for their design. And I really think that what I covered in the late editions, the spring semester, as I was refining the project management and the CI that I was teaching, as well as vendors, suppliers, that I really think that would have worked well for those earlier civil engineering groups. Because what would happen is that in previous years, the electrical and mechanical and bioengineers would all get together on teams, and they would design something. And now, of course, not all teams would have a mixture of students, but there were some One good example, I had one project group, they were in mechanical engineering, and they were building a wearable ophthalmoscope for an ophthalmologist within the South Coast region. And so on that team, they had 2 mechanical engineers, an electrical engineer, and a bioengineer. So a really diverse group, but they needed all those perspectives to create the device. Whereas civil engineering didn't play with the others until much later. And I never got through to the civil engineers until they scrapped that part of the curriculum. Originally, the civil engineers only did something where all students got one project, and then they did a secretive competitive bid process, which I think a lot of the stuff that I covered in the spring semester would have done really well with. Now, for the bio and electrical groups, most of what they got was the single lecture. Occasionally one of the groups, usually from bioengineering, would drop by, but for the most part, that was all they really got. But with mechanical engineering, I was able to tack on a lot more. Starting in the second year, there was a mandatory consultation. At one point during the year, either in the fall or the spring semester, students were mandated to come to me. Each project group within mechanical engineering, usually about 12 groups a semester, 12 groups a year. They would be mandated at some point to come and visit me to talk about the research help that they needed. And that was part of their grade. It was a small part, but it helped, and the groups would all come and see me. And eventually, Don left teaching senior design, and he was still managing the lab, and a new lab manager and a new senior design instructor from mechanical engineering came on board. And he actually wanted to install some quizzes, which Don and I were a bit reluctant to do. But Dr. Fairdouse and I came up with quizzes for students, more of as a way to enforce them paying attention. But the downside of this was that the mandatory visits went away. So there was a quiz now instead of the mandatory visits. Dr. Fairdouse didn't want to mandate students come and visit me. And I saw the number of student visitations drop pretty precipitously. So the early feedback I got was pretty positive. It was very well received at the beginning. Don loved it. I was actually pretty nervous when I first taught the class. It was the first time it was the second time I taught an engineering related class specifically to students, and I was kind of nervous about it, but it was very well received, and Mr. Foster really liked it, and I was able to take that work and then build out an instruction portfolio for students a little bit later based upon that class, focusing in on them as underclassmen. So seeing them in their freshman design classes and their other introductory classes. There was some debate about whether or not to keep the data management and the competitive intelligence sections in the spring. The electrical engineering and bioengineering faculty approached vendors and suppliers differently than mechanical engineering. A lot of the lab specimens and other biological agents that bioengineering purchased, they purchased through the university through a direct contract. So they weren't really they weren't really in need of competitive shopping in the same way that the mechanical engineers were. Just didn't really fit what they had because they had to work within the parameters set by UMass Dartmouth administration. You can only buy from this contract, which is basically one vendor. So they weren't as, eventually over time, the spring lecture wasn't as well attended as the fall lecture, which focused more on, I guess you would say, the traditional things a librarian would teach. And as I had talked about before, the change in mechanical engineering faculty did lead the iteration to be different toward the end. Whether that was good or bad, I don't think I'll know. But it did lead to something that I guess I probably could have improved on had I remained at the university. So what helped? And I guess I was a little bit pedantic on the screen with this point of having a faculty member champion the cause because, well, that really did help. As I said before, it was a bit of a cheat code that Mr. Foster, Don, his wife was a librarian, so he kind of got it. But he also had taught as I had mentioned before, he had taught the technical communication class, which all engineering students take as a writing class. And Don really lamented the writing of the students at times. He said, I wish students had more practice and more exposure to writing in engineering. I really wish they had more of this because he said they come to my class and they write and he's like, they're not up to where I would hope for them to be by this point in their careers, especially with engineering becoming more and more of a subject where you have to communicate and you have to be able to do this succinctly and clearly, but also you actually have to have something of substance to talk about. And Don also really lamented the fact that, particularly for the literature standards, he really lamented when I brought up I wanted to teach standards. Don said that he was really disappointed by the lack of standards education within the school. And other engineering librarians that I've talked to have made similar statements. They're sort of disappointed with the fact that standards don't get emphasized probably as much as they really should. And it's not just standards, but biological test methods or codes, laws, things like that. They're not as stressed or as emphasized as what you would see in industry. And possibly a result of that is many faculty members in engineering, particularly ones who don't spend a lot of time in industry, it's not something that they get routinely exposed to in an industrial setting or in a corporate setting. Whereas in the business world, standards are a much bigger thing. But it really helped to have a faculty member champion the project and champion the idea of this. There's more to it than that. It helped that I was able to speak with other colleagues, not just at the university, but also with other engineering librarians through other societies, and they imparted things onto me. But it also helped that I kind of wanted to do this. This was something that I wanted to teach. That was my undergraduate background. It was something that I really wanted to do. And being able to have and see most students at a funnel point, and at a point that I related to myself, not because I was in a STEM major, but because I was in their shoes for many of them. I I knew what it was like to be an upperclassman and never really think about how I could get the information I needed to do my projects. I would just, fiddle around on, I'm just going to say it, the Google, uh, because that's just what I did, right? I know how to search for it. I got this. And there was something there that I related to, and I felt pretty passionate about. Um, and then as I reflect on this, would I have changed anything? And I think, yeah, there are things that I would have changed. I would have pushed harder to get in all the sections earlier. I'd pushed a lot harder, actually. And I would have pushed a lot harder to get into more of the underclassmen courses. In general, I was pretty successful at getting into mechanical and bioengineering classes, which would allow me in time to scaffold. So I could scaffold knowledge and introduce students to the academic literature at an earlier point in their careers. I do remember having feedback with the instructors for these classes and them actually telling me that students use this stuff in the class. They use the material that I taught them for finding patents or finding articles in the class, and that students appreciated it. And I think I would have pushed a lot harder to get into more of the undergraduate classes for underclassmen, freshmen, and sophomores. And I think I would have flipped a little bit more of the material and done a little bit more of sort of required reading early on. One of the things that I did when I was developing the class, I tried not to lecture the whole time. There's lots of studies and materials that students don't want to be lectured to, or people don't want to be lectured to. Period. Any learner, whatever. They don't want to just be lectured to. And people want hands-on work. When I went to undergrad, we had this conceptual framework through the College of Education, and it was that learning is a very social construct. That was sort of the key point to this conceptual framework, and I wanted to make as much of the material about the social construct of learning and interacting with your peers and in the groups that you're in and trading ideas. And so what I did for each class, in the fall semester, I would ask the faculty, are your students having difficulty finding some piece of literature? Whether it's an article, whether it's a patent, whether it's a technical report. Are they having any difficulty finding any literature? And I'd get a couple responses back from the faculty member, and then I would use some of those examples in class. And it gave me some context. I could point to a real-world problem and something that some class members were really doing. And in the spring, I did the same thing, but with components and with materials. Was there a component or material that you're having difficulty locating? And what is that component or material? And again, I used these examples in the classes. While I was also in the classes, I tried to have some sort of talkative or interactive material with each each thing that I covered. So toward the later iterations of the class in the fall semester, we started out with, I would bring a baseball bat in, and I pulled out an ASTM standard, which was about the displacement velocity of a ball off a baseball bat. And I was able to use this as an example of There are standards governing how fast a baseball can come off of an aluminum bat. And the reason that there are is because whether through nefarious cheating means or through just, negligence of testing, if you exceed those speeds, then a pitcher or a third baseman will suffer serious injury or possibly death because they could not react to a ball speeding that fast. It's a major safety issue. And it was something that would resonate with the class a little bit. Plus, it's, a little sports related thing, and many of the students seem to like that. And so I'd get students to discuss around the baseball bat, and then we talk about patents related to baseball bat designs, and we talk about finding literature on whatever topic students needed. And then in the spring, there were other things. Usually what I would do is with the material or component that students couldn't find, we would set the stage with how can you find this material, and then after you've done this, create some kind of plan to then just like designing up a document for a CI purpose or a project management purpose. How are you going to evaluate your options in the marketplace and choose what is best for you from both a cost perspective and a design perspective? I wish I would have flipped some more of the lecture earlier on, but it's not something that I had gotten to. And so how could I modify this here at Stanford in a new gig? Stanford uses the quarter system, which is taking some adjusting for me to get to. And one of the things I've noticed is that senior design isn't really as integral to the experience here. It's a thing, but it's not the end-all be-all for students. And this is a much larger school. The undergraduate populations are roughly equal, but the focus is very much more on graduate students, and there are more graduate students than there are undergrads here, which was definitely not the case at UMass Dartmouth. In fact, there are more postdocs at Stanford than there are graduate students at UMass Dartmouth. So it's a much larger scale and it's a much larger scope. There are fields that I didn't really have any faculty invested in. There was one faculty member very early on who did aviation engineering at UMass Dartmouth and then retired. And there's a whole department here at Stanford. And it's very different. And the scale is much bigger. And I'm not entirely sure if I could cover everybody even if I wanted to. Granted, there are more engineering librarians than just me here. But it's a little bit different of an environment. And there are some resources here that I never really dreamed possible. And I think that's of benefit. Stanford has they call it the D School. And I've actually used the wrong punctuation. It should be a dot rather than a hyphen, so don't tell anyone. I'll change the slides later. But the design school here originally spun out of one of the mechanical engineering design labs at Stanford. And it's a school that blends together several of the faculty from various departments on campus. And it's very integrated to not just engineers, but to other students. And it's not something that exists at UMass Dartmouth, but it's something that for the students who do go through design school pathways, it's something that I think I can find pretty useful connections to. There's also a student chapter of the American Society of Engineering Education, which exist here at Stanford. It's mostly populated with graduate students. They have some journal clubs and some symposia, and it's a small group, but they're pretty vibrant and they're passionate about teaching, and many of these students are teaching undergrads. And graduate students are kind of a nice way to hit both lower and higher. The graduate students you influence today become educators and professors themselves later, perhaps, and having positive interactions with them, no matter where they go, can help, and can help with teaching what it is that we as engineering librarians want to teach. And then there's a technical communication program here at Stanford that's run through the School of Engineering. So tech writing at UMass Dartmouth is principally the domain of the English department, but technical communication at Stanford is the domain of the School of Engineering. And there's a stronger historical relationship between the TCP here at Stanford and the engineering library than there is, at least during my time there, the relationship between that side of the English department of UMass Dartmouth and what I had. These are three things that, while I may not have the same sort of curriculum here at Stanford, senior design may not be as integral to the experience, and there may be more students, but there are other ways that I can take the things that I teach, whether through the D School, whether through ASCE meetings, whether through technical communication classes, and impart what it is that I want to teach. So we are coming up toward the end, and so I have some discussion questions. And they're up here on the screen. I'll read them out, and then if you want to fire away in the chat or whatnot, we can do this. But first up, how do you reach difficult populations or students who don't normally pass through your program? And then how do you become more embedded? And I use this in quotation marks because I know embeddedness is kind of loaded as a term. But how do you become more embedded in the curriculum, or even if you can, do you want to be? Can you manage the scale of it? Not every school is fortunate enough to have the resources to be able to scale. Can you manage that? And then how do you assess what students already know and what they took away from you at the end? So I want to kind of open this up in the chat, and I don't know if there's voice or anything like that, but here we go. I get referrals from professors who do not have time to teach information literacy. Yeah, that is it. Part of the scaling issue, I think, is that particularly for something like engineering, which has a super dense curriculum, and it's hard to fit everything into. It's hard to fit everything anyway into the curriculum, and then you want to add something else. That's really difficult to do, and so I imagine that there are. Oh, these are questions I'm hoping I always answer. Well, I might throw something out there. I want to see what everybody else has got to say. But one of the things that I have mixed up feelings about is, yes, it is possible that it is possible that referrals will work, But there's two issues with this, and one is that a class you have to go to, or at least in theory you have to go to class, right? Not everybody does. Whatever, right? But seeing students one-on-one and doing the same sort of demonstration multiple times, that is taxing, and it is it is something that is difficult to scale when it's much easier to do this in one class. I probably could have certainly managed teaching all 4 classes in the fall and all 4 in the spring for each department, but having everybody in the same room together was a nice bit of scale. It did free me up to do other things. Let's see here. Working with classes the last librarian taught. In a way, that was sort of what I did at UMass Dartmouth. Basically, my predecessor, there were certain things that Don Foster wanted to have taught, and my predecessor did that. And that sort of became what I got, although I didn't really get any specifics of what was taught before. And so I sort of had to come up with it myself in a way and ask other engineering librarians. And I kind of wish that at the time I did have that, at least some sort of curriculum support or something to go off of. When I was going through my undergraduate education, there was this beg, borrow, and steal philosophy where don't take anything and make it your own at first, right? Like don't reinvent the wheel. Steal somebody else's stuff, borrow somebody else's stuff. Every other teacher has done it. This is what I do. Let's see here. Surveying courses, curriculum mapping, that's something, when I was looking at ways of building out this curriculum, and I started from the very top, the senior design, right? And that was sort of the crown jewel. And to me, it was a capstone class, not just in what its intent was, but it was a capstone class in as far as this is, by the time students get to this, what have I done to support them to get here? And how can they tie this all together? And so part of the curriculum mapping that I did was trying to find introductory design classes and introductory courses that I could be, I guess, more embedded and reach difficult populations the same way. Engineers, part of the plus and minus of engineers is that they'll figure things out on their own, which means they can do the stuff, they can do the work, and they will solve a problem very relentlessly, but they don't ask for help all the time. And they're not very, very good about, many of the engineering students that I worked with had this uneasiness about, I don't want to admit or show that weakness of any kind. And that was something that I did struggle with, but reaching students much earlier as freshmen and sophomores. There's some great memes that go around the internet talking about, overly ambitious freshmen, who are really wide-eyed, and they come to class 15 minutes early and they do all the assignments and the optional readings, and they're just super excited about learning. And then you get to like the lazy seniors who are just like, oh yeah, I know what I need to do, right? Like this is no big deal. I've already seen everything there is to know. And so getting in I did some curriculum mapping to try to find those classes so that maybe as lazy seniors, I wouldn't be teaching them something hopefully totally new. Let's see here. Video tutorials and lab guides and things, that is a good idea. Something that I know, Graham Sheriff at the University of Vermont, he's an engineering librarian there. He's got some tutorials that he puts out to his design classes before the presentation. So before he goes in, he's got these tutorials that he uses, and he's gotten, at least I think he's gotten the buy-in to do this. And the problem sort of is that are students actually going to do the material that you assign them? But I think it's not fair to assume that students won't do it. I think that you do have to plan for students not participating and not doing it, but I don't think it's totally fair to assume that they won't. Let's see here. One of the things, so there's a question about, do I feel the need to promote exercise using tools like Novel or Access Engineering and their CRC handbooks? Several of the things that you listed, like Novel and Access Engineering, I didn't have at the time. So it would probably be useful, and it'd probably be something that could be done. But there's the resource constraints. I don't have this material, so it's more difficult to use it and demonstrate it. Let's see here. Grad students being international students. That's something that I saw a lot at UMass Dartmouth. And most of the grad students who approached me for some sort of consultation similar to this, they actually asked me some of these questions that, when I said before, you know, students would contact me after graduation, or there were grad students who would contact me and ask these questions. And, you know, I kind of thought at first, like, did they get this at some point? Like, is this something that was imparted onto them? But then, you know, but I don't know what they had learned before. And you know, I would ask, and usually, you know, students would say, nah, we never got shown this. Nobody ever showed us this. And I've even had it here at Stanford. I had a PhD candidate here who said that they just used Google Scholar, and they found me somehow, and I sat down with them, and, you know, in 30 minutes showed them Compendex, and they were just totally blown away by what you could find. So it's a problem, I think, that more engineering librarians have or see than, not necessarily that they might admit to or that they know of, but it's out there, even at places like Stanford. I did actually, there's something here in the chat about a foundation across courses and having a one-page document laying out the program, sort of this conceptual framework. This was actually something that I had constructed myself toward the later stages of the class the later stages of the senior design class. The dean of the School of Engineering had changed, and this was something that I presented to both him and to some of the department chairs about. These are things that I would like to do and expand the work of what we do in the library. You know, and in some ways, I'm a bit sad that you know, I won't be able to follow through with it, but I do hope that my successor, whoever they are, will be able to. So there's this comment about first librarian to have an interest in the engineering program. Um, all the faculty will let me go, students international, and they're asking for this in-depth research assistance, which I think is something that people are seeing more and more of. Yeah, you can get thousands of answers, but can you get the right answer? Or what happens when you do your little simple search and you didn't find exactly what you're looking for, and you know it's there, you know it exists, um, but you can't find it. Um, I I don't I didn't get the sense that um, I had to. I didn't always get the sense. Sometimes I felt it a little bit, and sometimes I didn't. But I didn't always get the sense that I had to be an engineer to do this. Um, I think that many of the students looked at this through this sort of, I don't want to say capitalistic business sort of model, but they said basically um, they wanted to see some value in the end. They wanted to see some return on the investment of the time that they were using to meet with me. I felt kind of that way. It looked very much like an economic, pure, cold, rational decision. Is me meeting with you worth my time? Um, and I think for most of the students that I worked with, they saw that. Um, and I guess seniors are a bit harder of a group to reach because even if you get good word of mouth, they leave. Um, it's like postdocs or anything like that where they just leave. Not because they did anything wrong. It's just it's time for them to go. They got bigger and better things to move on to. Um, and I think that one of the things about embeddedness is it does take time. It takes time to know what students it takes time to know if the students that you have are learning what you're teaching them, and what they're taking away from you in the end. I would go to uh, the end projects, so the ends of the projects, and when the students would present, and you could see the students and I could talk to the students and ask them about their projects, and I could tell for some groups that they got something out of this, that they learned something about how to purchase some sort of component, or they learned about searching through the patent literature because maybe they could patent something. I found that they could do this, but initially this was tougher for me, even if I had a background in education, because I didn't have as much of the contextual knowledge, and that only comes with time and embeddedness and repeated results. It was I felt more embedded in the mechanical engineering curriculum as I went through the years. It took me 4 years to get to a level where I thought I was doing pretty good with them.
Since we are hitting the end of our time, we have some time for a few more questions. Zach, if you want to reply to a couple more things.
Sure. Let's see here. Uh, librarian support for graduate students. Yeah, that is something that graduate students, I think, in general, are a neglected population. Um, and this is partially not a fault of their own. It's hard enough to um, basically be the day-to-day operator of a lab or something like that. But then there's all these things that you're expected to know. When I remember talking to several friends who are in academia and several the students that I was working with, and most of them said something to the effect of, "It's already assumed that anything you need to know, um, you got it. You've already learned it." Um, whereas there's not as much teaching of those more foundational things like how to do a patent search or anything like that. It's more of the you'll figure it out on your own, or you'll get to it yourself. And I think that graduate students and postdocs, there's a bit of again the same sort of problem, not just with engineers, but with I think any graduate student. Um, there's a fine line between you're here and you don't want to admit that you have this weakness or that you don't know this thing because you're a PhD student and you're supposed to be super brilliant. Um, I think that supporting graduate students and offering them and marketing yourself as some way to support that builds on what students got as undergraduates. I think it's very important. And it is difficult to scale. Meeting larger institutions where you have, several thousand engineering students. I know at the University of Michigan, they have 9,000 engineering students alone. That was the population of UMass Dartmouth's entire student body. It's hard enough to meet with, just, 1 or 2,000. It's much more difficult to meet with more than that, and scale it in that way.
Okay, and if you want to respond to one last question, and then we should head out.
There is a project called there's a credible statistical grade literature project. One of the things that I'm familiar with from a European sense is called Open Gray. I'll type it actually in the little box here. And it's a project that it's technical reports and research reports. It's mostly European based, but they've got a lot of really good stuff there. That's one of the very first things that sort of came to my mind. There's also GrayNet, which belongs in the same. See if I can find a website for that. Somebody got it? Okay, great. Yeah, they're connected to Open Gray as well. I've used them in the past, and I really like what they've got. Yeah, APED is very interesting. because ABET does talk up this game of what are you preparing students to learn, and there's not quite a requirement, it seems, with something like SciFinder Scholar, for example, where graduating students should know how to use SciFinder by the time they get out for accreditation. ABET doesn't quite have something as explicit as that. It might be nice if there was something like that. Maybe dream or petition about it, I don't know. But seeing how faculty and how administrations are talking about how they prepared their curricula for ABET helps with curriculum mapping. It helps with assessing what students should know. And I think it helps with how you can find those gaps that you can come and discuss information.
All right. Well, thank you, Zach, very much for presenting. This was obviously very interesting to everyone. And we will also have a recording of this up on the STS Information Literacy Chat LibGuide. So thank you all for attending. Yeah, it was really great. I appreciate, Zachary, you coming for this, and then everybody else, thanks for attending.
Great. Thank you.